Hello everyone, Mr. John here from Areteem Institute. In this week's Thursday Tidbit, we're going to be solving some AIME problems in preparation for next week's exam. Remember, AIME I is next week, 3 hours for 15 questions. These really are more challenging or more involved questions in some cases at least. All question answers are 3-digit integers 000 up to 999. Hopefully everyone does well. We all wish you good luck on that. If you want to learn a little bit more about the AIME and get some good tips, you can always check out our blog post that I will link in the description below for some more information. But in this video, we're going to solve 2 questions from some old exams and talk a little bit about the strategies we might use to solve the problems. So this first question is a number 8 from 2003. So about halfway through the exam, exams have trended a little bit more difficult over years. So this might be a little bit earlier than number 8 if it was appearing more recently. But let's take a look. So we have a sequence of 4 positive integers, and you really want to key in on information given and the details. So we have positive integers. I'm going to highlight that right off the bat here. We have this sequence of 4 of those, and then we're given that the first 3 terms form an arithmetic sequence. So those first 3 terms we know are arithmetic, and the last 3 terms are geometric. So we have geometric in that way as well. Lastly, we know that the first and 4th terms differ by 30. But let's deal with these arithmetic sequences and geometric sequences bits there as well. So we have to deal with both of them in this case. Now, anytime you have an arithmetic sequence, one nice fact, and it's especially useful here because then it makes things a little bit simpler because the last 3 are a geometric progression. If you have an arithmetic sequence, they're symmetric about the middle. So my preferred way of dealing with this arithmetic sequence is, let's call that middle term x. And then arithmetic means we have a common difference. So the 3rd term in that arithmetic sequence we could write as x plus d. That first term would be x minus d in that case there. Now, things are a little bit messier for our geometric progression then as well, because now our common ratio, if we think about this geometric progression here, we're multiplying by r in both cases. So kind of instead of a multiplication symbol, let me use the dot here for times r. And that ratio here is a little bit messy. Well, we're going from x to x plus d. So basically we're multiplying by x plus d over x, We have this common ratio every time. Probably can do that in your head anyway, but this is telling us that our final term, this 4th term here using the geometric sequence, is x plus d squared divided by x in that case. Now, we have all of our sequence written out. We have 2 variables here, so that might seem a little bit problematic because we're only given one final piece of information. These first and 4th terms differ by 30. So just writing this out, literally what do we have there? Well, the difference between that 4th and the 1st term, We know it's increasing, so we don't have to worry at all about which one is bigger or smaller or things like that. This difference of those terms is 30 in this scenario there. Now, let's just manipulate this a little bit quickly so we can multiply everything by x and distribute that x square stuff out. So we get x squared plus 2dx plus d squared. Remember, I cleared the x's there, so then we have minus x squared plus dx for the x minus d term, and then this is equaling 30x on the other side. Now, luckily, x squared terms cancel. We do still have kind of a quadratic in terms of d, but let me just write the positive terms all on sides. So we have d squared plus 3dx equals 30x from here. Now, at this point, you could solve for x. We're going to do something similar for that in a second. But I want to write out one note and one tip that can sometimes help in problems like this here. Note that 3dx, 30x, right? D squared is a multiple of 3. So, right, note we can write d is equal to, let's say, 3 times k for some k. Integer k again, this is another integer, things like that as well. So that kind of is one simplification that we could look at and do here. It's not necessary you could solve for x directly, but let me just mention that this is a useful tip. So d squared is 9k squared, then we have 9kx, we're getting rid of all of the d's, equals 30x. And now if we solve for x, we get that x is, right, subtract the 9kx, pull out the x, divide, we have 9k squared divided by 30 minus 9k. Like I mentioned, you could have checked this earlier for kind of just solving for x in terms of d. That would give you something similar. There would be a little bit more values to check. The nice thing here is that k is an integer. In fact, k is a positive integer. Remember that we have positive integers here, meaning that this denominator, 30 minus 9k, needs to be positive. So we actually only have to check a couple things. If k equals 1, does it work? No, that doesn't work. If k equals 2, right, does that kind of work there, right? That's not going to work either. We actually have to have k equals 3. So we actually can solve this, and we have to have k equals 3. And that tells us that then if k equals 3, that tells us that d is equal to 9. So that kind of is what we have there. And then we also have to have our value of x, right? If we solve for x, then by plugging this in, we will get that x equals 27 in this scenario there as well, right? And so one thing I want to say when we're checking these, right? Remember, I'm skipping a little bit of work there. Convince yourself that k equals 3 is the only one that works, right? You might have to look at a few more things just to make sure that we have positive values for all of our things, but actually then k equals 3, d equals 9, x equals 27 is the only one that we have. So, finishing things up from there, what are the 4 terms? Well, our 4 terms are going to be x minus 9, so 18, 27, 36. Those are our first 3 terms that are the arithmetic sequence. And then for our geometric sequence part, you can solve that x plus d squared divided by x. You will get 48 for our final term. This tells us that the sum, which is our answer to the problem, right? We want to find the sum of the 4 terms. This is going to be adding everything up, 129 in that case. So sum of the 4 terms is 129, finishing up the problem and double checking everything there. Okay, so pretty straightforward one where you write out what you know, you do some algebraic manipulations, right? This is a little bit of mix of the number theory, right? We have positive integers, and when you have those positive integers, this equation that you end up with, even though it's just one equation, you actually have enough information to solve that because we're using integers only. So that's something you want to keep in mind and look at there as well. Okay, so let's look at our second question here. This is a number 10 from the AIME II in 2009. It's a pretty long question, but it's actually not as bad once you start getting all of the details and setting up a picture and summarizing stuff from there. We have 4 lighthouses located at points A, B, C, and D. And let's start looking at this first set of information we're given. We're given that lighthouse A is 5 kilometers from B, B is 12 kilometers from C, and A is 13 kilometers from C. So we're given information here only about A, B, and C. And don't overthink things about what about D, things like that. Focus on what you're given and what you know. So right off the bat, 5, 12, 13 in a triangle should be setting off alarm bells, or actually these are happy bells in this case, because we know that we actually have a 5, 12, 13 right triangle to set stuff up at the beginning. So we have B, we have A, and we have C. And we know that this is, say, 5, 13, and 12 for BC as well, which I'm not going to write for what's coming in just a moment. So for an observer at A, the angle determined by the lights B and D is equal to the same angle as C and D. So these are giving us angle bisector information. So I want to just draw this out then in terms of those angle bisectors. So if we have the angle from A and B, right, and that to D, so we have this kind of angle bisector written out there. And this is a little bit of a spoiler and a preview of stuff to come, but right, we're now saying that D is somewhere on this line there. So this line is going to contain point D. Now, to an observer at C, the angles from A and B, so let me draw out that angle here too. Don't worry, we're going to clean this up on the next page in terms of our diagram as well, right? We have this other angle bisector here as well. So this angle is the same as this angle here. And D is on this line as well. So right off the bat then, we actually know that D is this point here. We have this unique point that is going to be the intersection of those two angle bisectors through kind of A and that point at C. Now, before we summarize this picture on the next page, we have a ABC right triangle. We have this angle bisector. So we're getting this congruent copy on the other side. So if we call this point here, and this is going to be very helpful for our setup of things, if we call this point A prime, then we actually have that AC A prime is isosceles. We actually have this second copy of this right triangle over there as well. So we're running out of room here, and this is something you should be doing on your scratch paper. So the other reason this is helpful is you're jotting things down. I would actually recommend, here I'm highlighting them on the screen, but actually write down the important information. So the next slide here is something like a summary of our relevant information. So we're being told again everything that was from the problem. We have our AB is 5, our AC is 13, we have our 12, so we have this right angle there. We are given information about these angle bisectors. So angle ACB. So this one up here, this angle is the same as this angle. And we also have the same for these angles down here. BAD equals CAD. And then, right, we know that point D. And the other piece of information that I want to remind us of is that angle A prime is then creating this isosceles triangle that we have there as well. So let me write this out at the top. So we know that A prime CA is isosceles. Now, there's a lot of different ways to do this. We have definitely some angle bisector things going on. Remember that we also have some right triangle stuff going on as well. So those are some things that we can keep in mind. So the way I like solving this question is, well, let's first look at kind of some angle bisector business. So we know that, for example, since the AD is an angle bisector, we know that, for example, A prime D, this ratio to CD, right, that ratio we have here is the same as the two sides. So this is 10 to 13. As a reminder, because we have this isosceles, we know that A prime C is equal to 13. So we know that those distances are there, and we have that information to help us out and look at in that case. Now, because of that, we can find both of those values, right? A prime D, CD add up to 13. Their ratio is 10 to 13. So this actually tells us that, well, if we want to find A prime D, right, this is going to be, right, well, if we start looking at the different ratios and stuff there, right, well, this is 10 to 10 plus 13, and then we need to multiply this by the 13, right? We have the ratio of those two sides, so the whole thing, A prime D, is 10/23 of the whole, which is 13. So not the super nice, most nice number, but we have 130 over 23 in that case. So we are given this length here then, or not given, but we can find that length as well. Now, remember, in the end, we're looking for AD. We're looking for this length here. And now, if we start thinking about this, if we look at this triangle, we know two of the sides of that triangle. We know A prime D, we know A prime A. Do we know the angle? Do we have information about that angle there as well? Well, we do, right? So note that actually we know cosine of that angle. So cosine of, let me just write it as A prime in that case, right? Cosine of A prime, this is that 5, 12, 13 triangle. So we can actually use the law of cosines. This is going to tell us then that AD squared, right? Let me write it out in symbols just as a reminder of the method we're doing then. This is A prime A squared plus A prime D quantity squared, right? Or that length squared there. And then we have minus 2 times A prime A prime D, and then cosine of A prime. So squeezing that in there, right? But just a quick reminder that that is our law of cosines stuff in that case. So it will be more clear when we write it out in terms of the numbers. So A prime A, this is 10 squared. A prime D, again, this is something you have to get used to sometimes on AIME questions in particular. Our numbers might not be the nicest. You have 3 hours to solve these problems, so there is plenty of time to do simplification and work carefully through all of those pieces. Now again, we know that cosine value here is 5/13. Now, I'm not going to simplify this all that much in this case, but I will give you a tip for doing this here, right? Okay, we have fractions, we're looking for common denominators and things like that there, right? You maybe don't need to fully simplify things, right? Try to simplify stuff in terms of, okay, can we find some common denominators? Can we find some expressions for writing this out and how you might go about simplifying stuff from there? So for example, we could write all of this in terms of, and whoops, let me just say here we have AD squared is, well, we could put it right 130 divided by 13. That is going to kind of cancel out a little bit there. So we can write everything with a denominator of 23 squared. Let's not even bother calculating that denominator in that case. It's okay if we kind of leave this that way as well, right? And depending on how you do the kind of numerator and stuff like that, right? Maybe we could write this as some different squares or things like that, right? So this could be like a 10 squared in this case, right? And we could write this times maybe 9 squared, and then times a kind of, sorry, not times 6 squared, and then times 13, right? So you don't need to necessarily simplify this fully. And what's the reason for that? Well, remember, we're looking for AD at the end. So if we draw our line all the way over here to where we're putting our answer, this is then telling us that AD is equal to, well, we're taking the square root of that. 10 squared, 6 squared, that's 60. Then we have a square root of 13, and then divided by 23. So remember that you don't need to actually solve numerically everything. There might be times when it's easier to go through and solve in terms of a prime factorization or things like that. But now we are ready to add up 60 plus 13 plus 23. And our final answer there is going to be 96. So that is our final answer for P plus Q plus R in this case. Recognize we have a right triangle, we have an isosceles triangle, and then angle bisector plus law of cosines actually is enough to solve the question from there. So even a later question, you don't always need fancy tools. There's not these super fancy tools that are necessary. You need to work carefully, work piece by piece with what you know and what tools you are comfortable working with as well. Okay, that will be a good place to stop for today. Again, good luck to everyone taking the AIME next week. Let us know if you have any questions below. And if you liked this video, please give it a like. Please subscribe to the channel for more updates. It really helps us out here. Otherwise, thank you all for watching. I'll see you next time. Goodbye.